Hey everybody. Today we're getting started with data manipulation and reorganization using R. I'm going to show you 4 of the main functions from the dplyr package. These are really essential for you. If you're just getting started with R, this is a great place to start. All the functions I'm going to use come from the dplyr package. That's one of the core packages in the tidyverse family of packages. And so we want to start out by loading all of those up with library tidyverse. I'm working in a Quarto document. I talk about that a bunch in my previous video in this course. If you're just dropping in here through like a Google search or something, I'll have a link to that up top, to that other video. When I'm working in my Quarto document, I can go to any of my lines of code and actually execute them with Command-Enter on a Mac, like I'm on a Mac, or Control-Enter if you're on a PC. And you'll see that library tidyverse is going to attach core packages, including dplyr, including a bunch of other things that may be important to you later on as you continue learning R. For instance, ggplot2 for data visualization. Right away, I am going to take a look at the data set that I'm interested in with a glimpse command, and that also comes from the dplyr package. So if you haven't loaded up tidyverse, you will get an error when you try and run that command. You can see that we have about 54,000 observations, rows, of 10 variables, columns. And they're including things like caret, cut, color, and clarity of all these different diamonds. As usual, we can learn more about our data set with the question mark command, so question mark diamonds. That's going to work whenever it's a built-in data set or one that loads with a package. You can see here we have prices of over 50,000 round-cut diamonds. By the way, you may have noticed that I put that request for help in my console, not in my Quarto document. In general, you want to avoid putting interactive commands like help commands into your Quarto document, which, Quarto is making something that's not going to generally be opened in RStudio, like an HTML document, whereas a question mark command will open in RStudio. So the first thing I want to show you is how to subset rows based on different conditions that you might set. And the command here is filter. By the way, this syntax here, dplyr : filter, just says look in the dplyr package for the command filter. And so the way we're going to use the filter command is first by passing it the name of the data set that we're interested in this case diamonds, and then the conditions that we're going to use to do that filter. In other words, to say which rows we want to keep. So I, to start off, just want to keep the diamonds whose cut is ideal. And you can see that I have taken the exact entry that I want to have in the cut column, ideal, where ideal is capitalized. And I have put the string in quotes. This is the value of a categorical variable. It needs to be in quotes. I've put more than one condition. That's great. I used a comment. I put comment caret greater than or equal to 3. So the resulting data set that I'm going to get out of this is going to only include diamonds with an ideal cut and a caret mass of greater than or equal to 3. Let's go ahead and execute that with Command-Enter. You can see that's the case. Here I only have 4 observations left. Still 10 variables. Filter will never change the number of columns or the order of columns in the output. It'll just affect the rows. Notice that I used a double equal sign here instead of an equal sign when I said I wanted to keep observations where cut was ideal. The double equal sign in R and in many other languages represents logical equality. So basically it's just going through this entire vector, this column that's called cut, and looking for matches for where cut is logically equivalent to the string ideal. If I only use a single equal sign here, I will get an error. Error in filter. We detected a named input. So what this is saying is that you are saying that you have an argument name inside of filter called cut. And that's just not the case. This is not the name of an argument. This is a logical condition. So we need that double equal sign. We can do many other things when you're using filter. One that I do want to point out is the OR operator. So this vertical bar is saying only keep the diamonds for which the caret is greater than or equal to 4 or cut is ideal. Contrast that with this previous example where I say I want diamonds where the cut is ideal and the caret is at least 3. Also here, by the way, I am saving my results. So, when I do a filter command or some other operation on the data set, R doesn't save it by default. And so if we actually do want to retain the result rather than just printing it, we need to assign it to something. So here in line 23, I'm saving this filtered data set as diamonds nice, and then I will print that out separately. I figure these diamonds have great cut, they have very large size, so they're kind of nice. The next thing I want to show you how to do is just to subset your columns. So instead of keeping all the same columns and filtering out rows, now we're going to keep all the same rows and just select some of the columns. The command here is select, and as with filter, the first argument is the name of the data set. After that, we just need to specify sort of which columns we want to keep in order. So whatever order I name the columns is the order that they're going to appear. As a very basic example, let's start with the diamonds data set and just select the columns price and carat. So I'll do Command Enter to see that, to send that command over to the console. You can see that the result is a data frame, technically a tibble, with about 54,000 entries, but now just those two columns, price and carat. We can specify our columns in many other ways. First, I can use this colon operator to say keep all the columns starting with depth and ending with Z. So, just as a reminder, let's glimpse this diamonds data set. We have all these different columns. This command here on line 37 and 38 is going to keep the columns starting with depth, including table price, X, Y, and then stopping with Z. So let's see how that goes. Still about 54,000 rows, still the same number of rows as before, but now just those 6 columns. We can select our columns by number. So for instance, this command is going to just take the first 4 columns of the diamonds data set. I put as a comment that that's not generally recommended, and the reason is that if I make some changes to the diamonds data set earlier on, for instance, just changing the order of those columns using, select, then the nature of columns 1 through 4 will be different. And so this command, where I use the 1 to 4 syntax, might give me some unexpected results. It's just a little bit less stable. So in general, something you can do, not the most recommended. The next command here is going to remove some columns. So just looking back at my original data set, I have these XYZ measurements of diamonds. Maybe I just want to lose those columns because, for instance, maybe I'm not going to use them and they're just clutter. And the way I'm going to do that is with the negative sign. So this is saying remove the columns in this vector. So remove columns called X, Y, and Z. There's the result. You can see now I only have 7 columns. I've removed 3. There are lots of helper verbs. I want to point out in particular contains, ends with, and starts with. So here on line 46 and 47, I'm only going to keep the columns that start with the letter C. So in this case, we get 4 columns: carat, cut, clarity, and color. By default, those are going to come out in the same order that they appeared in the original data set. So that's why carat is coming first. The last helper verb I want to show you is everything, which just specifies all the other columns. So here on lines 49 through 51, I'm going to create a data set starting with diamonds that puts carat up front and then includes everything else. So there we go. We can see that. The next command I want to show you is arrange, which is just going to change the order of the rows. It's not going to change the number of the rows, not going to change the columns at all. In general, the arrangement will happen alphanumerically, so smaller values will come before larger ones, and A's will come before B's when we're talking about strings. If you have a factor variable, so something that is coded in specifically as a factor variable, and it has a built-in order, as is the case with the cut variable here, where fairs come before goods, which come before very goods, and so on, then that order will be respected. So here on line 59, I am asking R to arrange the diamonds data set by carat, so it'll go small to large, and then to break ties using cut. And so it will use that built-in order. Let's go ahead and execute that with Command Enter. And you can see that we have the smallest diamonds first, or the least massive diamonds first with the 0.2s. There are a lot of 0.2s for carets, and so those ties have been broken by cut, where very good is ordered before premium, as I talked about just a moment ago. Sometimes you might want to have the highest values first, either to start at the end of the alphabet or to just get the largest numbers. So you can wrap the name of the variable in DESC to make that happen. So, for descending. So here, when I do that just for the caret variable, you can see I have the most massive diamonds first. So the very largest diamond in here is 5.01 carats. Interesting, by the way, that it has only a fair cut. All right, the last function I want to show you here is the mutate command, which is going to add or modify a column in your data set. Once again, the first argument should be the name of the data set. And then after that, you want to just give the definition of the new column or the column that you're modifying. So here on line 72, you can see I'm going to take the diamonds data set. I'm going to create a column called mass_G. And I'm going to get that just by taking the caret column and multiplying each value by 0.02. And this is just reflecting the fact that a caret, when we're talking about diamonds or other gems, is 0.2 grams. While I'm at it, I'm going to modify the cut column just to illustrate. You can see that right now, cut has entries that are all capitalized. Capital FAIR, etc. So I'm going to use the toLower command to make everything lowercase. So that'll make 2 changes to my data set. Let me go ahead and execute that. Right away, you can see the difference in cut. You can also see that I have an 11th column here that will be called, as you can see by looking down here, there it is, mass G. In a moment, I'll render this document. You can see the HTML that'll show all 11 columns. So those are the 4 main functions I wanted to talk about. But before we wrap up, I just want to point out that they all have some very important things in common. First of all, they all the functions have verb names. And that makes sense because functions do things. Filter, select, arrange, mutate. Secondly, the first argument inside each of these functions is the name of a data set. It's the thing that's being acted on. And then subsequent arguments in each of these functions say specifically how to do the thing, how to do the filter, the select, the arrange, the mutate. And this makes data manipulation and reorganization much easier because you never have to think too hard about which arguments go where. That syntax is common to all the functions that you'll be using. Very last thing I'm going to do before this video ends is to click the render button here. That's going to create an HTML version of all these notes I made for you. I will post these on my website, both the Quarto document and the rendered HTML. I'll put a link in the description below if you're interested. Here's that rendered version. You can see both the comments that I've made, as well as the code, as well as the output.